Hi guys, so the topic of the presentation is lithography process in CMOS. So let's see what are the contents of this presentation. So the contents are introduction to the photolithography, lithography steps, what are the steps in the CMOS and types of lithography. So coming to the next slide. So, introduction to lithography. So, what is meant by lithography? So, it is come from the Greek word. So, the litho means stone and graphy means to write. So, basically, photolithography means transferring patterns onto a substrate by using a light source. So CMOS are fabricated on a silicon wafer, as you know, and the wafer diameters are of suppose, for example, 200 to 300 mm. So on each step, the different materials are deposited or pattern or each. So let us discuss next. So these are the steps in the of the lithography. So first step is the wafer cleaning. After that, barrier layer information and photoresist application, pre-baking, mass alignment and exposure, development, art baking, etching and stripping. So let us discuss one by one of them. So the first step is the wafer cleaning. So what is mean by that? So initially the wafer is cleaned through chemically and which is used for to remove organic, ionic and metal impurities. So these are the diagrams of the wafer cleaning. Okay, so the second is the barrier layer information. So, what is meant by that? In barrier layer information, after putting the substrate, the SiO2, that is a silicon dioxide layer, which serves as a barrier layer, which is deposited on the surface of the wafer. So, coming to the third step, which is the photoresist application. So, what is meant by that? The photoresist is a light sensitive organic polymer and it is applied after the SiO2 layer. So, whenever the photoresist is applied on the surface of the wafer, which is done through by the high speed centrifugal spinning, which is also known as the spin coating. It produces the thin uniform layer. And the property of the photoresist changes where it is exposed to the light. So basically there are two types of photoresist. One is the positive and second is the negative. So let us discuss one by one. So in the positive photoresist, it is exposed to the UV light and the underlying material is to be removed. So in this diagram, as you can see, in this resist, it is directly transferred the pattern from mask onto the wafer. So this is the photoresist applied on the substrate. This is the mask, and it is exposed to the UV light. So this blue color material, it is remain as it is because of the mask protects it and from the UV light, and the remaining part is exposed. So let us discuss the negative photoresist. So in negative photoresist, just behave opposite to the positive. If it is exposed to the UV light, the resist cannot be removed. So in this diagram, as you can see that in the positive photoresist, the blue color remain as it is and the green color part is removed as it is exposed to the UV light. And in the negative photoresist, as you can see, the green color part remains as it is and the blue color part is removed. So let us discuss the fourth step of the photolithography, which is okay. So apart from that, so there are certain components of the photoresist. First one is the polymer. What is that? So it is the solid organic material. It transfer design patterns to the wafer surface. Second is the solvent, which is used to thin the resist so that it can be applied on the wafer by a spin-on process. And third one is the sensitizer. So these are used to control the chemical reaction during the UV exposure. And four is the additive. Additive means various added chemicals to achieve the desired process result such as dyes, which is used to reduce the reflection in the photoresist. So coming to the next, which is pre-baking. So in pre-baking, it is the step which is almost all the solvents are removed from the photoresist. The photoresist becomes photosensitive after pre-baking. So photoresist is pre-baked at around 90 degrees Celsius to 100 degrees Celsius for 5 to 30 minutes. So after that, the fifth step is the mask alignment and the exposure. So a mask or a photo mask is it's one of the same. Is of square glass plate with a pattern combination of metal film on one side, pattern transferred onto a wafer surface. So for a given IC, there are multiple masks which have to be aligned for the proper device fabrication. So the mask material, which is what is the mask material? What is made of? So it is made of borosilicate glass or quartz with a sputter deposited chrome layer on the top. So these are the basically the common materials, mask materials. It is not limited up to that. There are many mask materials. So and so after that, the types of mask alignment: first is the contact, second is the proximity, and third is the projection. So let us discuss one by one. So first one is the contact alignment. So what is mean by that? In this alignment, the wafer is brought physical contact with the photomask. As you can see the diagram, this is the silicon wafer. Up this photoresist is applied to the end, and there is a mask. So the distance between the mask and the wall part is negligible. So, because of this contact between the resist and mass is very less, very high resolution is possible. So, the problem with the contact alignment is that the fragments trapped between the resist and the mask can damage the mask and cause defects in the pattern. So, what is the remedy of that? We can use the another alignment, which is the proximity alignment. So, in this alignment, which is similar to the contact, but the distance between the silicon wafer and the mask is little far away. So, as previous, you can see in the contact alignment, the distance between is negligible, and in the proximity, the distance is more of that. It's something 10 to 25 micron is there between them. So these gaps minimizes but may not eliminate the mask damage. So approximately 2 to 4 micron resolution is possible without proximity printing. So after that, the third one is the projection alignment. So what is mean by that? So in this alignment, it avoid the mask damage entirely. So see, there is a silicon wafer is there and the mask is there, and the distance between them is very far, and there is one lens is there which protects the alignment, which protects the silicon wafer from being damaging. So an image of the pattern on the mask is projected onto the wafer, which is many centimeter wide, as I discussed already. So to achieve this high resolution, only a small portion of a mask is imaged, and it is about 1 micron. So these are the various types of mass alignments. So after that, the sixth step is the development. Development is the process in which the exposed and the non-exposed area is dissolved by the developer. So in the diagram, we can see that there is one type of nozzle which is sprayed or spin around on the this solution of the silicon wafer. So most common, what is the most commonly developed solution? So the solution is tetramethyl ammonium hydroxide is using the concentrate, which the concentration of this is 0.2 to 0.26. So the developer is important, very important in controlling the development, the uniformity of the silicon wafer. So basically there are two types of development. First is the spin and second is the spray development. So in spin, The wafers are spun and the developer is poured onto a rotating wafer, and the spray in second type spray. So in this developer, the spray, it is sprayed rather than pour onto a wafer by using a nozzle. So as you can see the diagram, this is the spray developer solution is used on the silicon wafer, which produces a fine spray over the wafer. So after that, the seventh step is the hard baking. So the hard bake is used to harden the final resist image at the temperature of 120 degrees centigrade to 150 degrees centigrade. So it will hold out the harsh environment of etching. After that, the etching process will be done. What is mean by that? It is performed either using the wet chemicals such as acid, or more commonly in dry etching by exposing the material to a bombard of ions. So basically, whatever the applied photoresist is there, we have to remove it. So this is the use of etching. So the photoresist will resist the etching and protects the material covered by the resist. When the etching is complete, the resist will stripped, leaving the desired pattern. So after that, the last step is the stripping. So what is meant by that? So after the image wafer has been etched, the remaining photoresist must be removed. So there are two types of stripping: wet stripping and dry stripping. So a simple example of the stripper is acetone. What is the use of it? It tends to remove the residue of the on the wafer, and most commercial organic stripper are phenol based. So these are the old steps of the lithography process. So after that, coming to the next slide. So there are various types of lithography. For example, electrobeam lithography, X-ray lithography, interface lithography, scanning probe lithography, charge particle lithography, and nano imprint lithography. So there are the various steps of lithography. Thank you.